So welcome to another installment of MBF Bioscience's TJIF webinar series, or TJ's Information Friday. As you can see, we've made a slight change from our previous application to this Zoom webinar platform. So we're excited to kind of come up to speed with that as well. Today, my goal is to provide you with an overview of our products, Vesselucida 360 and Vesselucida Explorer. And by the time this short webinar comes to an end, my hope is that you'll have a better understanding of one, how Vesselucida 360 works, two, what's possible for reconstruction within that program, and three, what sort of data you can collect from Vesselucida Explorer. There are a lot of different capabilities and possibilities with both of these programs, so rather than just talking about them, I'm excited to share what they can do. But before I do that, I'd like to put the reminder out there that the overall success of today's webinar is in part due to the questions that you come up with. And since this is a different platform than we've used in the past, I figured it would be important to quickly cover how we can go over those and send questions. So let's do that. When you develop a question during the webinar, please send it in. Submitting a question is as easy as finding this Q&A button in the Zoom webinar panel at the bottom or the top of your screen, depending on where it's located. And then once the question and answer panel opens, simply type the question in and hit enter, and that should pop up in my question and answer section. Please forgive me if it takes a minute or two to find the question that you've asked and to answer it. As I mentioned before, this is a little different than what we've done in the past, so I'm slowly catching up to speed, and I'm also doing this on my own. So working on two screens, seeing the questions and doing the tracings and whatnot. It might take a minute, but I will do my best to try and get to all those questions that come in. Lastly, this webinar is being recorded and will be available later to view, and a link is going to be sent to the email address that you provided during the webinar sign up. With all that being said, I think it's time to get going. So let's get started. On my screen now, you should be able to see Vesselucida 360. This program, it was built specifically to reconstruct microvasculature, and it doesn't necessarily have to be within the brain. We've worked with multiple different organs through multiple species, and it's a nice program to be able to kind of differentiate from the neurons that we're used to seeing and working with. This is specifically made for vasculature, which is why it is Vesselucida 360. I'm going to quickly load in an image stack, and similar to our other programs, one of the most efficient ways to open them is to simply drag and drop from the image directory on your PC. As you can see now in this 3D environment, we do have an image stack of vessels that have been acquired. I believe this was a two-photon image, and I also believe this was stained with tomato lectin. Two important things there are the imaging itself and the staining. So although this was a two-photon image, Vesselucida 360 is not restricted to working with specific image modalities and imaging types. Two-photon images work, brain scans work, slide scanners work, cleared tissue samples have worked in the past, and so have light sheet microscopy images. So typically, as long as you can view the vessels, we should be able to trace them. But more importantly, what we're looking at here for an accurate reconstruction is a nice filled vessel. So as we look around, we know that vessels are kind of these tubular structures. So as we look, we can see that most of the vasculature in this image stack has been filled in quite well and fully. But we can also see, as I start to click and drag to rotate, that some of the vessels still have that tube-like structure without the full staining encompassing the whole vessel. So what we see here is we see typically, depending on the staining itself, we can see that the walls tend to be stained a little bit more significantly than the interior or the middle. This isn't an issue for the most part. what does happen at some points is the algorithm can get a little confused depending on which one you're working with. It can get a little confused and not get the full extent of that diameter. So to work around that, we do have a couple of filters that I'm going to show in just a minute. Before I do that, I thought it would be nice to just cover a couple of different ways that we can reconstruct the vasculature. And if you've ever used Neuralucida 360 before, the image tracing modes are the exact same and the methods are the exact same. The only difference here is that we've defaulted to this voxel scooping method, and I can show that with this cool new annotate feature that we did not have in our other webinar presentation platform, or whatever you'd like to call it. So the voxel scooping method is, the way that it works is it wants to find the center of the staining of your vessel, and then it wants to push its way all the way to the outer edges to get that full diameter calculated. What I'm doing here is I'm working with our user guided mode, which is a semi-automatic tracing. And I'm clicking and I'm not holding anything down. I'm just hovering my mouse over the filled vasculature. And as I'm doing so, you'll notice that these circles are almost chain linked and brought on top of the vasculature itself. And as I left click, the program will do a much more refined diameter calculation, and then it will fill that in as best it can. Here's where the difference is between our previous program that we've discussed, Neuralucida 360, and the one we're looking at now, currently, Vesselucida 360. An innate part of vessels is that it's a closed network, right? The vascular system is one gigantic loop, but the second that we cut into our tissue, we're severing many of those connections. So the important thing for us when we're reconstructing vessels is to be able to create those looping structures, those anastomoses. As I work with this user guided mode, I'll actually make this full screen so you folks can see this a little better. As I hover over, we can see that the circles are still pink, but as I get to a pre-existing vessel that's been traced, the inverse color of that vessel will show in a nice sphere. And then I can left click to create that connection. And now we can see we have our first loop within this vessel, within the vascular structure here. If I go to edit and I go to points, we can see each individual point that the algorithm in this user guided mode has placed for us. And we have the ability to work and manipulate each of those individual points as we see fit. The goal here is to try and create as accurate of a representation of the diameter of each vessel. As I mentioned before, each point is going to be presented here, and they can all be manipulated individually, and all of them will be colored white other than the branching points that we create. Anytime we create a loop or anytime we create a bifurcation or trifurcation, we're going to have those points be red. And if it's a red vessel, they'll turn a bluish color so you can still see that as the user. As I move up along this vessel to ensure my accuracy, we can see that there's a little bit of a gap between the edge here and the edge on the other side. If I show and hide the tracing, we can see that this pericite, or the varicosity within this vessel, has pushed the algorithm to one side. So the way that we can handle that is we'll go to points mode once more. I can click and drag the individual points as I see fit. And then by holding down the control key, I can click each one of the points to select them. And then I can adjust the thickness to get that measurement as close as I can to the accuracy and the diameter of that vessel. So working through the entire structure in the user guided mode might work for some. Other people might want to work with our automatic mode, and that's extremely valid. The nice thing about Vesselucida 360 is that you can work interchangeably with any and all of these tracing modes. You can start with your automatic mode and make any necessary corrections with the user guided mode as you see fit, by connecting segments, so on and so forth. So on and so forth. As I mentioned before, we do have some filters that will help ensure a better tracing, especially when we see areas like this, where the vessels are a little bit more hollow and the diameter calculation might be a little bit more roughly done. So as I hover my mouse over this vessel, because the staining is a little bit not inconsistent, but the areas where the saturation occurs, it's not as uniform throughout that vessel. So one way to alleviate that, if I full screen, I guess would be the phrase. If I remove the full screen here, if I go to the image panel, the image tab in the 2D window, we do have a batch filter icon, and these are a part of the program. It's built in. In a previous webinar, I have discussed the Golgi filter, but today I'm going to just be discussing the two filters that would most likely be applicable to your vessel images. Once you've selected your image stack from your computer, you can go ahead and click this wrench icon to open up the configuration window, and this is where we'll choose our filter type. From this list, typically the two most applicable filters would be the closing filter and the vessel filter. And for this image, we'll use the closing filter. The difference between these two is that the closing filter looks to kind of blur the staining in between the boundary edges of each vessel and make a more uniform staining so that the algorithm can trace more accurately and efficiently. If you have staining that is a little bit more punctate, it's not entirely necessary to run this closing filter, and it's not always necessary to run the filter on every image. Some images might work well just as is. Others may need this closing filter to help really blend that staining and make it more opaque rather than having that tubular structure. The other filter that I mentioned was the vessel filter, and it almost works in the opposite manner. The closing filter looks to kind of blur and make a more opaque staining so we don't have those tubular structures. The vessel filter is going to work by, if I slide this out of the way, it's going to work by finding the vessel edges and making those a little bit more clear and crisp. So when we apply that vessel filter, the edges will become more solid, and it will allow the algorithm to detect that boundary edge for the diameter calculation a little bit more efficiently. Rather than running the entire filter now and having you sit and wait, I've done this already. So if I zoom out, we can see, and I'll hide the tracings, I'll just remove them. We can see our original image right here. And then what I'm going to do is I'm going to click and drag the filtered image into the program. We don't need to save the data. And right now we're getting a window that says we only support one image stack at a time. This is okay. What I'll do is just simply click OK. So now we have our original image here. If I go to the organizer tool under the image tab in the 2D window, we can see that there are two image stacks open. We have our vessel 1 and 2 closing, which is the filter that has been applied, and we have our original vessel 1 and 2. By clicking the eyeball icon here, we're going to remove this original image from the 3D environment, and the program should show and push forward that closing filtered image. So by removing that eyeball, we can see now that the closing filtered image has been opened, and we can see that the areas that were a lot more non-uniformly stained, I guess I'll say, have now been filled in a little bit better. So if I just return to home, if I go to vessel, automatic mode, and I'm not going to go through the settings. Typically, if you want to get the most optimal image for your reconstruction, I would recommend going through the settings, but since this is just supposedly a brief demonstration, I'll just click trace, and we can see how the program does at the default settings. One question just came in, and it was, can this program be used for vessel segmentation? Yes. So right now what we're doing is we're generating the data. So we're reconstructing the image that's on the screen. And then once we have this vessel data present, the reconstruction, we can bring this into Vesselucida Explorer, and then we can start to explore the quantitative data and the segmentation that's going on here. As you see here on the screen, we have a pretty well reconstructed vessel network in the center, and then we have a couple of colors that are showing the different segments that are occurring. We have 18 different vessel networks within this reconstruction here. And for demonstration's sake, I'm going to say that this is as accurate as we'd like. There may be one or two connections. I'll just make this one connection quickly. By going to the edit mode, we've just finished our automatic reconstruction. So I'll go to edit, I'll go to connect, and it's going to put all of the vessels into points mode for us. At this point, I'm going to click and drag from our blue vessel up here. I'll find the point and I'll drag down and release my left mouse button on top of the yellow point at which I want that connection to be made. And then in just a second, we're just having the program catch up and think with us. That yellow vessel should turn that blue color because we've gone from blue to yellow. And now as I leave the points mode, we can see a nice uniform color throughout the image. If I go to File and Save As, I can save the data file in the location that I want. So I'll go to my desktop and call this the vessel test part 1. And then by clicking on this icon here, it's our Save and View button. It's going to push the reconstructed data into Vesselucida Explorer for us. That way we don't have to go and look for it on the network, on our desktop. We don't need to look for all those icons. We can just open the data as it is. This, I guess, would be the second part of the demonstration where we talk about Vesselucida Explorer, and that's the partnering program to Vesselucida 360. Vesselucida Explorer is going to work specifically with the data files that you generate, and this is where all of the quantitative reporting is going to happen. You'll notice that we no longer have the image stack, and that's twofold. For two reasons, I guess. The first is that we've spent our time accurately reconstructing the image stack as we saw it in Vesselucida 360. So all of your hard work is going to relay exactly what we saw into this data file. And then secondly, we're not showing the image because these data files are significantly smaller than the image stacks that they come from, which allows us to work much more efficiently and quickly with this as opposed to the image stack itself. That's also going to allow you to install Vesselucida Explorer on computers or even laptops that aren't necessarily these beefy, powerful workstations that we might have specifically assigned to Vesselucida 360. What I'm doing here is I'm going through and I'm just selecting a couple of these reports that we'd like to run. And the two ones that I really like to point out are the Analyses analyses and the binned segments analysis. So if I return to the Analyses one quickly, what we're doing here is we're running a report on the loops that we find within our networks. So the important thing here as well is that we are designing this report for you as the user so you can define what a loop is. Different researchers are going to consider different things. I said different too many times, but essentially what we're doing is we're giving you, the user, the capability to define your research. If you're looking for these large networks and these large loops, you can change the diameter of the continuous vessel to a higher number. If you want to limit that to a smaller loop, you can do that as well by changing the contiguous diameter or the number of nodes that it reaches to be considered a loop. Once we hit this maximum value, we have 10 here. Once we hit our 10th node, we're no longer allowing the report to go after any sort of loops that have 11 branching points or higher. The binned segments report is also nice because this is going to group our segments per diameter. And if we lower this down to something like 2, when I click OK, we should see all 4 of these reports being generated. And so now if I just briefly move these over, I can cover the other ones in just a second. But Let's hide that. With this bin segment analysis, what we're doing is we're kind of grouping the vessels together in a segmented fashion based on their diameter. So if we wanted to do this with a much larger network, we would be able to see exactly how this breaks down per diameter of the vessel. And this is a user specified value as well. You'll notice as I click within my data table, the different parts of the network are going to be highlighted, and that's to show exactly what we're reporting on. And similarly, we can see which structures are involved in this report. As I leave this bin segments report, I'm going to go over to the vessel loops. So this was the anastomoses report. And this is where it's important to know the difference between the looping structures. So as I click up and down through the network or through the data table, we can see exactly which loops are being reported. And this one, for example, is a very similar loop. So if I zoom in here, we can see just the difference between this 6th and 7th report is a minor change in how the detection is going and reading this loop. They're both reaching 10 nodes. However, the diameter and the surface area that we cover is, I would say, pretty drastically different, but that is for further reporting. Again, this is just a summary of our network. As we click, we can see what is being reported on. And then lastly, with Vesselucida Explorer, pardon me, with these data tables open, we can click this current Windows button at the top. It's going to ask us if we'd like to save one last time. And this time when we do, it's going to show us the network location that we've saved to. And then we can open this in Microsoft Excel, and we'll keep the exact same structure as we had in Vesselucida Explorer, except now we can work our magic with Microsoft Excel. Whether you need to do averaging, pivot tables, graphs, anything that you can do in Microsoft Excel, you can apply that to your data that you've just generated. And then you can do a lot of these post hoc analyses that we're interested in and that we're looking for. I am talking a little slowly, so I'm going to speed things up just a little bit as we move into a much larger network. And that dovetails pretty nicely with the question that Sava just asked. It's a nice example stack, but there are networks that are much larger. Can your software handle them, or may we need to break them into smaller chunks? Fantastic question. And this will, I just said it will dovetail nicely. We do work with small stacks like this. We can also work with 2D images that have stained vasculature, and we can go all the way up to full organs. So one example that I love to show is something that we received from one of our customers, Miguel Gama Sosa. I think he's in the webinar now. And I'm so excited to be able to have permission to share this. This is from research that he had done a couple of years ago at this point. But what we're going to show here is a full brain that was cleared out and imaged with a microCT, I believe a scanner. But as we click and navigate through, we can see as we load the data in, it's a little bit grainy and not at the full resolution. But as we start to work with the data, the resolution starts to come to fruition, and we can see the full data and the full range of the intensity of the pixels and all these little vessels that were imaged. This is an absolutely stunning image that he had taken and worked to acquire. And so to reconstruct this, you can just go to your automatic settings and apply it to this image and have it run. This is a 33 gigabyte image set, and I believe on our most powerful machine, I think these took about 2 to 3 hours to reconstruct, which is not to say that it's a little long, but it does a very nice job in a small amount of time. There's not necessarily a reason that you would need to break the larger images into smaller chunks. If you'd like to, we do have a tool here, our subvolume tool, and that will allow you to generate ROIs, or regions of interest, within the stack itself. And then from there, you'll be able to work in a more segmented fashion. One of our developers likes to talk about it as attempting to eat a pie. If you try and eat the whole pie at once, sometimes that's a little bit more difficult and you slow down. But if you work in a more piece by piece or slice by slice time frame, things can be worked out much more efficiently and much more manageably. Another thing that you can do, and this is going to be a little segmented, so I apologize, is if you have regions of interest that you're interested in specifically that you'd like to pull from your larger data set, we can work with our contour drawing tools in 3D. So as I click the contour button, it's going to put us into slice mode, which is going to put us at each individual plane. So as I move my slice slider, I guess, the contour slider, we would be able to trace a bunch of different contours here. And then just to show the resulting data, let me bring that up. This is what we would be able to generate, something like this. So I've gone ahead and I've drawn 3 contours, 1, 2, 3, and then I went through and did the automatic reconstruction. Within this small section, we're able to run what we call our closed surface analysis. And what it's going to do is, rather than running the report on the entire vessel network within this brain, we've gone through and we've broken down all of the vessels that fall within just this closed section. So as I click within this data table, it's a little bit tricky to see because we have so many vessels poking around the outside, but you can see that there are vessels within here that are getting highlighted and being reported on. So if you need to pay attention to the hippocampal region, you can simply draw a couple of contours at different plane levels throughout the stack prior to tracing. And then when you get here into Vesselucida Explorer, you can really look at those segments and look at that region with, I guess, a more developed and a more in tune and more accurate measurement rather than having to parse it out on your own. That is a really wordy explanation, but there are a couple of different ways that you can work without having to break your data into chunks. If it does get to a point where you're generating these massive multi-gigabyte data sets and it seems to be slowing down the computer, I would highly recommend working with that subvolume tool to help limit that. And if it gets to a point where you might need to break it into smaller chunks, we do have a tool that will allow you to crop your image stack right within Vesselucida 360. So you don't need to worry about doing anything prior, which might limit the amount of data or the resolution that's coming out within those cropped sections. We can keep it at its full resolution and you can work with it just as you would with the whole image stack. We are just about at the end. We have about a minute left. If there are any other questions, I would be more than happy to answer them. There's a question about finances and about the cost. I don't have those specific answers, unfortunately. I can have one of our sales representatives reach out and answer that a little bit more directly. And if you do have questions, there is a survey at the end of this, and we would be more than happy to get back in touch with you after the survey is filled out. Thank you, thank you for the kind words, Jean. This is a pleasure to present. I guess the one last thing I didn't get to cover here is our puncta detection and reporting. Maybe that's something that I can share a little bit later in a different webinar. I'd also be interested in showing the different filtering tools and different filters that we can apply if that's something that people are interested in. But just a brief glimpse of what the puncta tool could detect. If you have proteins, if you have mitochondria, if you have blockages within the vascular network itself, as long as it's labeled, our puncta detection should do a very nice job of getting those reconstructed. And then we can report on that. in relation to distances with your vessels, in relation to different puncta themselves, and we can do a nice cohesive kind of colocalization reporting as well. So those are some things to be aware of and to be I guess excited about as well. It was a pleasure to be able to put this together for you all. Thank you so much for your attendance and for your questions. Miguel, thank you so much for all of your help and for allowing us to show this. Again, it's always a pleasure. Please fill out the questionnaire, I guess, the survey, that's what it's called, at the end of this webinar. And if you do have any other questions, please feel free to visit our forums page. There's a great area for discussion between different customers, and you might just learn something a little bit extra. So again, I want to thank everybody for their time today, and I'd like to wish you all a happy weekend and enjoy the sunshine and summer. Thank you very much, and have a great rest of your day, everyone.